Okay, hi everyone. This video is to go through very quickly 2-3 questions on current electricity and DC circuits. And this will be a very speed run and a taster of what's going to come up when we see word problems. Okay, so question 1, we have a series circuit here, resistors 3 ohms, 6 ohms. On the figure above, draw the symbol for voltmeter connected to measure the potential difference across the 6 ohm resistor. So we want to measure the potential difference. We will normally use a voltmeter and we will connect it parallel to what we want to measure. So over here I'm going to draw it parallel to the 6 ohm resistor, so it will look something like this. Alright, so there we go, voltmeter across the 6 ohm resistor to measure the potential difference. The ammeter reading over here is 0.20 ampere, so this is actually the current. Okay, the current or I is 0.20 ampere. Okay, so what does this mean? This means that this is a series circuit, so the current through the entire circuit will be the same. It will be 0.2 ampere over here. Okay, so first calculate the potential difference across the 6 ohm resistor. Okay, so with this, over at the 6 ohm resistor, we have current 0.20 ampere. We have our resistance 6 ohm. Now we look for potential difference. Okay, so we will make use of the V equals to IR, the relationship. Okay, so I over here is 0.20. R would be 6. So this just nice 1.2 volts. Okay, so you need to be very sure about your units. Okay, next, the combined resistance of two resistors. This is a series circuit, so these two resistors added up will give us 9 ohms. Okay, next, to find the electromotive force from the dry cell. Okay, this is actually, in a way, we're looking for the total potential difference. Okay, or looking for the V total. Okay, so we are, in order to look for the V total, we need the total current and the total resistance. So same thing, V equals to IR, but now we put the total here. So total current is the same, 0.20, total resistance is 9. So the EMF from the dry cell is 1.8 volts. Okay, so just a reminder, potential difference and EMF are roughly the same thing. It's just that for EMF we refer to the power source. Okay, now then, given that the circuit is closed for 30 seconds, okay, calculate the amount of charge that passed through the ammeter. So here we will need to make use of the charge formula. Charge Q is equals to current I over time T. Okay, so charge equals to current over time. So current that we measured was 0.20 ampere, time 30 seconds. So 0.2 divided by 30. Okay, so this would be 0.00667 coulombs. Okay, 0.00667 coulombs. Okay, so even this may be a small number, but there's actually a lot of electrons for the charges that must have pass through. Okay, alright, so this is the end of question 1. For question 2, we have two resistors of resistance 10 ohms and 50 ohms connected in parallel. Then a cell is connected across the resistors over here. So the current over here in the 10 ohm resistor is the current. Okay, let me label it here. The current is 0.15 amperes, and the current up there in the 50 ohms is 0.03 amperes. So calculate the current through the cell. So meaning we are looking for the total current over here. Okay, so what is the total current through the cell? It is just adding each other, so 0.18 ampere. Okay, why? Because the current over here will join back to the main circuit, the current below will also join back to the main circuit, so we need to add both these currents up. Next, the potential difference across the 50 ohm resistor. So we have current, we have resistance, we need to find the potential difference. Okay, so V equals to IR for this one. So the current over here 0.03, resistance 50. So this is 0.15, yeah, 0.15 volts. Oh, so small. Okay, 0.15 volts. Last but not least, the charge passing through the 10 ohm resistor in 5 minutes. So we'll need to look at the charge formula. So Q equals to IT. Okay, so charge equals to current times time. So charge is equals to okay, so charge is equals to the current is 0.15 ampere. Okay, and the time t 5 minutes. So this one is actually 5. We have to convert back to standard units, so times 60. Okay, so here we will have 0.15 times 5 times 60. So this is actually 45 coulombs. Okay, and with this I realized that I made a mistake earlier. So let's go back to our first example. Okay, so it's not I over T, it's just I times T. Okay, so this one would be I is, okay, first one, the I is 0.20. Okay, time is 30. So this is actually 6 coulombs. Okay, 6 coulombs, or 6.0 coulombs. Take note of the SF. Okay, alright, so question 1, question 2 done. Okay, question 3 is actually like primary school question. Just need to decide like what happens if one of the lamp breaks, or what happens if like there's a switches here, like you put a switch here and there, so does it affect anything? So in the circuit shown below, the battery lights up all 4 lamps. When one of the lamp melts, the other 3 lamps stay on. So which one melt actually? So you just need to see, okay, check the circuit, check the current, and see how will the current flow. Okay, so the current will flow in this direction like this, and over at this junction it will split to 2 directions. Okay, and last but not least, they will group back into the main junction, the main branch. Okay, so which lamp melts? The answer is actually B, because even if B is the branch at B doesn't work, the current can still flow through the other lamps, and the other 3 lamps will work. Okay, so here the answer is B. Okay, so that ends the short video on a taster of word problems in electricity. Bye.